Okay, let's spend a little bit of time exploring triangle angles and then a shortcut to similar triangles. First, the triangle angles. Okay, let's give a quick reminder. The sum of any triangle's angles will be 180 degrees. So if we take the measure of angle 1, measure of angle 2, and measure of angle 3 here, because this is a triangle, that has to add up to 180 degrees. So let's go ahead and write that out as an equation. Now I'm going to write another line in here and establish another angle. So that's going to be called an exterior angle. This is angle 4 right here. It's the angle that's formed by the two lines that are right by the pointer there. And it's called an exterior angle because it's not inside the triangle. It's outside of the triangle. And let's look at a definition of an exterior angle. It is formed when one side of a polygon, like a triangle, is extended out to form an angle with the adjacent side. So I extended this side out. Here's the adjacent side, and then we have this angle 4 here. Now what's interesting is angle 1 and angle 4 are supplementary angles, right? And we know that supplementary angles always add up to 180. So we can write that here. Measure of angle 1 plus measure of angle 4 equals 180. But wait a second. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 was also 180. So measure of angle 1 plus this thing is 180. Measure of angle 1 plus this thing is 180. So those two things must be the same, right? And we can write that. We can say measure of angle 2 plus measure of angle 3 equals measure of angle 4. Well, that's really interesting, isn't it? So here we have these two angles inside the triangle here are equal to this exterior one over here. And you could do that with any of the sides. You could create exterior angles over here, and the same rule would be true. So we can create a rule around this. How would we describe this? Well, we can say that the measure of this exterior angle is equal to the sum of these two. What should we call those? Well, they're not exterior, so let's call them the opposite. They're inside. We'll call them interior angles. And they're not the interior angle 1 here that's right next to angle 4. They're the ones that are kind of on the opposite side. So let's call those opposite interior angles. And let's write a rule here. The measure of the exterior angle of a triangle, like 4, is equal to the sum of the measures of the opposite interior angles, like 2 and 3. There you have a very interesting rule. Okay, now let's go over to talk a little bit about triangle similarity, which is one of the most important concepts in geometry. And let's remind ourselves first that similar figures have all angles equal. So if you have all the angles of two triangles equal, they're similar. And I've drawn two triangles here, A and B. And I didn't measure the angles yet, but if we only measured just two of the angles, let's say triangle A has an angle measuring 61 degrees, that would be the one right here, and another angle measuring 87 degrees, that would be the one up here. And we could also measure those two angles. This one is 61 degrees, and this one is 87. So A and B each have two angles measuring 61 and 87 degrees. So what could we say about those triangles? Well, if you think about it, if we know the measures of two of the angles of a triangle, we can always find the third because they have to add up to 180. So 61 plus 87 plus 32 degrees, which is what we've written right here, is equal to 180. So triangle A's third angle has to measure 32 degrees, but so does triangle B's third angle, right? And that means that all of the angles are of equal measure between triangle A and triangle B, which means that they're similar. So if you have two triangles and you know all three angles are the same, you can say, hey, those are similar. But you can also say, and we'll write this as a rule, we'll call it the angle-angle rule. If two triangles have two equal angles, they're also similar because they must have that third angle be equal too. Great job.